So in our second video on sequences, we're going to be looking at how to find the nth term on linear sequences and how to find the first 5 terms of a sequence when you're given the nth term, and also how to work out any term of a sequence when you're just given the list of numbers. So before we start, let's have a little refresh on what a linear sequence is. So a linear sequence is where the difference between each term to term value is the same. And so it's really important that, because there are several types of sequence you can get, and there's no use of words of linear or quadratic, or potentially, although there is geometric sequences mentioned in exam questions, it's really important that you can understand what each sequence is and be able to spot what, from a list of numbers, whether it's linear, quadratic, or going to be geometric. So in this video, what we're going to look at is looking at find the nth term of a linear sequence. Now, there are several videos on YouTube, and there are several ways in which a teacher might teach you. So there's quick ways and there's ways that will enable you to understand what it is you're actually working out. Now, as well as the easy methods and most efficient ways are probably the ones you're probably going to use for answering questions, it is really important that you understand why it works, because when you move on to more difficult questions or the next level up from particular topics, that's where your understanding comes into question. So as well as understanding quick shortcuts and easy ways of doing things and simpler ways of doing things, never forget how important it is to actually understand why it works and how it works. So in terms of method, I'm just going to read through this and then I'll show you how it works. Now, if the method and the steps don't make any sense, usually methods in maths don't really make any sense until you start putting them to practice and start relating to actual steps in answering a question. But let's have a look what they are. So method 1, step 1 shall say, is find the difference between each term. Now the sign is important, so if you see that a list of numbers is getting bigger, then it's going to be a plus. If the sequence is going down, it's going to be a minus. So if the difference between numbers in a sequence is going up in 2s, so for example, let's actually write this down. So if I was going for 2, let's say 5, 8 and 11, you can see here that the difference is 3, but it's really important you write plus 3. And if I had a sequence of 10, let's say 7, 4, 1, you can see here that yes, the difference is 3, but it's minus 3 because it's going down by 3. So the signs in which you write down the difference is really important. And when we're talking about the difference, that's these numbers here. So not the numbers in the sequence, it's the actual difference, including the signs of those. Now for step 2, now if whatever the difference is, that n will be in the formula. So for this sequence here, as the difference is minus 3, minus 3n is going to be in the formula. And with this sequence here you can see the difference is positive 3, so it would be positive 3n would be in the formula. Now for positive 3n you don't have to write plus, but you're not going to lose any marks if you do. But when you write, you only sort of identify signs if they're minus. If there's no sign, you just assume it's plus. But that's what step 2 actually means. Then moving on from that, step 3 is then compare the difference value in step 1 to the first term in the sequence. Now what this means is, as you can see in, if I just hashtag this, in hashtag 1, our difference is minus 3. So what I want to do is I want to compare it to 10. So what do I have to do to get from minus 3 to 10? Well, I need to add 13. What do I need to get from positive 3 to positive 2? Well, I need to take away 1. And then the final step is then add this, connect this to step 2. So if this here was our step 2, then all we need to do is add 13 to it. And this is my nth term formula. And here, as I've got minus 1, I just need to add minus 1 to this, and this here is my nth term for that particular sequence. Now, once you've got the nth term, to work out the value of any term, all you need to do is simply substitute the n value into the formula, and you can go from there. So, for example, from this, if I wanted to work out what the 40th term was, then all I've got to do is swap n equals 40 into this formula. So what I have is minus 3 times 40 plus 13, and I would work that out. For this one here, if I wanted to work out the 58th term, well, that's when n equals 58, so it'd be 3 times 58 minus 1, and I could go from there to work it out. Now, if I've kind of rushed through that, do not worry, because I'm going to go through quite a lot of examples now on how we actually find the nth term. So in these set of 10 questions, what we've got to do is we've got to find the nth term and use the nth term to find the 40th term. So, looking at the first one, we've got here, so number 1. Now I'll try and colour code these. So number 1, we've got 9, 16 and 23. So first thing I want to do is work out the difference between each term, so I can see it's going up in plus 7. So that means that 7n is going to be in the formula. And then what I then need to do is then decide what do I need to get from 7 to the first number in the sequence, which is 9. Well, I need to add 2, so that would be 7n plus 2. For number 2, I've got 4, 11 and 18. So again, I work out the difference, and the difference here is plus 7 again. So I'm going to have 7n, and then I need to have a look at, okay, what do I need to go from 7 to 4, where I need to take away 3. So then I've got minus 3, and there is the nth term formula. For number 3, we've got 6, 2, minus 2. So you can see here that the sequence is going down, and it's going down by minus 4. So I'm going to have minus 4n in the formula, and then I need to think to myself, what do I need to do to get from minus 4 to 6? Well, I need to add 10. So it'd be 4n plus 10. Now, if you do have a negative n, then what you could do is you could write this as 10 minus 4n, which is exactly the same, because in this, my 10 is positive, and here my 4n is negative, and my 4n is negative is there as well. So you can write it in one or two ways, depending on whatever you prefer. For number 4, we've got 1, 7, 13. So again, working out the difference. So here we've got positive 6. So I'm going to have 6n in the formula. I then need to compare my 6 to the 1, which is, I need to take away 5. So it'd be 6n minus 5. Now, the reason why we're using n, so if I just go through it, hopefully that step kind of makes a bit of sense. So if I just try and explain how all of this actual method works. Now again, that's a very, very short way of doing it, which is absolutely not a problem. No idea what I'm doing there. So let's go for this one. An attempt. No. Let's just delete this as it is. So with number 5, let me just go through how this works in the correct way of what your thinking should be. Now, like I said, it is really important you understand why these steps work. Yes, the 4 steps I've showed you is probably the easiest way of finding the nth term of a linear sequence, but when you start moving on to quadratic sequences, it's a completely different method. So for number 5, we've got 3, 0 and minus 3. Now, in the last video we talked about n. Now, n is the position of each of the numbers. So the first number when n is 1 is 3, when n is 2 the second number is 0, and the third term when n is 3 is minus 3. And what we're doing is we're trying to get, the whole point of the nth term is to start with these numbers here and get to that set of numbers there. So the first thing we want to do is then work out the difference between the two. So here we can see that the difference is minus 3. So we've got minus 3n. Now, the first term is 1. So if I substitute 1 into minus 3n, so when n equals 1, I'm going to end up with minus 3. Now, generally speaking, when you repeat this to find the first term of any term when you get to this, basically the n kind of disappears. And then what you need to do is from this, which is we've got minus 3, but I don't want minus 3, I want positive 3. So you then you think to yourself, well, what do I need to do to minus 3 to get to 3? So, and there we go from there. So if I had n, 1, 2, 3, I had the numbers in the sequence, which are 3, 0 and minus 3. And then I've got minus 3n, so I'll end up with minus 3, minus 6, minus 9. And again, all I've done there is substituted the n number into my minus 3n. And then from this, what I then want to do is then decide what do I need to do to get from the minus 3n number to the number in the sequence. And then from there, we are adding 6. So the formula then will be minus 3n plus 6, or we could write it as 6 minus 3n. And we go from there. Now, so hopefully that kind of makes a bit of sense as to why the whole 4 steps work. All I've done is just kind of simplified it by giving you steps to do. So obviously you can feel free to use those 4 steps, but it is really important you kind of understand how it works and the methodology towards those steps and how it gets you the correct answer. Now I have noticed that I have not worked out B for any of these questions, so what I will do is I will quickly run through the answers for these, and you can, or if you want to have a go at these, you can do. So for the first one we had, which was 7n plus 2. For B we've got 7n take away 3. Should be numbers. For number 3 we've got minus 4n plus 8. For 4 we've got 6n take away 5. For 5 we've got minus 3n plus 6. For 6 we've got 3n minus 3. For 7 we've got 2n minus 5. For 8 we've got 4n plus 5. For 9 we've got minus 7n plus 8. And finally for 10 we've got 4n plus 3. So to find the nth term for the 40th term for each one, what we need to do is swap n for 40. So for the first one we're going to have 7 times 40 plus 2, which gives us 282. For number 2 we've got 7 times 40 take away 3, which gives us 277. For minus 4n plus 8, so here I'm going to do minus 4 times 40 take away 3, which gives me minus 163. For question 4 we're going to do 6 times 40. Now again, all we're doing is swapping n for the number 40. And why 40? Because we're working out the 40th term. So 6 times 40 take away 5 is going to be 235. Minus 3 times 40 is minus 120, plus 6 is minus 114. 3 times 40 take away 3 is going to be 117. 2 times 40 is 80, take away 5 is 75. 4 times 40 is 160, plus 5 is 165. Minus 7 times 40 is minus 228, so it'll be minus 272. And finally 4 times 40 plus 3 is 163. So to find the 40th term, all we need to do is swap n for 40, and again 7n means 7 times n, 5n means 5 times n, etc. So moving on to find the first 5 terms and the 100th term. So this is kind of where we're working backwards to what we did previously. So now the correct way of working this is we want to work out what the first 5 numbers are. So the first 5 terms are when n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. And what I need to do is substitute these numbers into each of these formulas, and I will work out what each of the 5 terms are. So for number 1, and again it's 5 that we're looking for, so here I'm going to do 4 times 1, which is 4, 4 times 2, which is 8, 12, 16, and 20, and the 100th term is going to be 4 times 100, which is 400. Now for minus 2n, we've got minus 2 times 1, which is minus 2, minus 2 times 2 is minus 4, minus 2 times 3 is minus 6, minus 2 times 4 is minus 8, minus 2 times 5 is minus 10, and the 100th term would be minus 200, and that's from minus 2 times 100. So Now, another way of doing this is, obviously you can do it that way, and that's the correct way of doing it, because obviously whatever term you're looking for, that's the number that you should be substituting in for n. Now, a quick way of doing this, now again, this only works for linear sequences when there's no powers involved or no, say, fractions, let's say, is this. Now, with question 3, we know that the difference, and let's just get rid of that. So the key thing to remember is that the difference equals the number of n, or what we call the coefficient of n. Well, so whatever number is in front of n, that's always going to be the difference. So with question 3, so if I just get rid of this arrow, so with question 3, I can see that the difference is going to be positive 3. So the difference is plus 3. With question 4, the difference is going to be positive 6, so it's going up 6. For question 5, it's going to be going up in plus 2. For question 6, now because there's no number of n, I can still see an n, so there is still 1. So the difference here is minus 1. For question 7, the difference is minus 3. So D equals minus 3. For question 8, the difference is going to be positive 22. For question 9, the difference is minus 5. And finally, for question 10, the difference is minus 10. So once you've worked out the difference, the next thing we then need to do is find out what the first term for each of these are going to be. So for number 3, let's write number 3, so because I know it's going to get outlined. So as we can see, the first term, well, to work out the first term, I'm just going to have 3 times 1, which is 3, plus 5, which is 8. Now, because I know that the difference is going to be plus 3, rather than me doing 2 times 3 plus 5, 3 times 3 plus 5, 4 times 3 times 5, 3 times 5 plus 5, you can slowly get confused and it's very time consuming. So if you think a bit smart, we know that difference is going to be plus 3. So once I've got the first number, all I need to do is just add 3. So here I'm going to have 11, and then going to have 14, and then going to have 17, and then going to have 20. For question 4, so again, to work out the first number, now technically you could do this. You could kind of scribble out the n, which I don't recommend scribbling things out because obviously you forget that they work. And then you've got 6 minus 1, which is 5, and that's the first term. Now I know with question 4 the difference is going up in 6, so this next number is going to be 11. 11 plus 6 is 17. 17 plus 6 is 23. 23 plus 6 is 29. For number 5, again, first 5 terms, and again I know I've got to work out the hundredths terms of these, it's not a problem, I'll do that last. We've then got 2 take away 5, which is minus 3, because again I just scribble out the 5, and then I've got the difference is going to be plus 2, so I'm just adding 2, so it'll be minus 1, 1, 3 and 5. For question 6, I've got 10 take away 1, so that's going to give me 9, and with question 6 the difference is going down in 1, so it's 8, 7, 6, 5. For question 7, I've got 12 take away 3, which is 9, and the difference is going down in 3, so the next one's going to be 6, 3, 0, minus 3. For question 8, we're looking at the difference is 22, so 22 take away 13 is going to be 9, and then all I'm doing is adding 22 to each of those, the previous number. So 9 plus 22 is going to be 31, and then add 22 gives me 53, then 75, and then 97. And then question 9, I've got my first term, so minus 5 plus minus 8 is minus 13, and the difference is going to go down in 5. Now be careful with negatives, so it'd be minus 18, minus 23, minus 28, and minus 33. And then finally with question 10, the first term is going to be minus 10 plus 30, which is 20, and the difference is going down in tens, so we've got 10, 0, minus 10 and 20. Now to work out the hundredths term, now this is where obviously if you haven't scribbled out the numbers it kind of comes in handy, because obviously, and also making sure you're reading the questions and checking you make sure you're doing what's asked of you. So for question, well, this is the answer for question 1, that's the answer to question 2. Question 3, so the hundredths term, which I'll do in green, is going to be 305. For question 4, the hundredths term is going to be 599. For question 5, it's going to be 195. For question, which question are we on? Question 6, it's going to be minus 90. For question 7, it's going to be 12 minus 300, which is minus 288. For 8, it's going to be 22 times 100, take away 13, which gives me 2187. Then question 9, it's going to be minus 5 times 100, minus 8, which gives me minus 508. And finally, it's going to be minus 10 times 100 plus 30, which gives me minus 970. So hopefully that all makes a little bit of sense. So here's some questions for you to have a go at. So if you want to pause the video, have a go at these questions, and then we'll run through the answers. Okay, so let's have a look at the answers that you should have. So with question 1, the difference here is positive 4, so we're going to have 4 in the formula, and then to get from 4 to 5 I need to add 1. In question 2, the difference here is 4, so I've got 4n, and I need to go from 4 to 7, so I need to add 3. Now for question 3, the difference is positive 2. To get from 2 to minus 3 I need to take away 5. In question 4, it's going down by 7, so it'll be minus 7n. And what I need to do to get from minus 7 to positive 3, well, I need to add 10. For question 5, it's going to be minus 6n plus 6. And then finally for question 6, it's going to be minus 6n plus 8. And then moving on to find the first 5 terms. So for question 1, it's going to be 6, 12, 18, 24, 30. For question 2, it's going to be minus 5, minus 10, minus 20, no, minus 15 rather, minus 20, minus 25. For question 3, the first number is going to be 11, and then we're going up in 3, so it'll be 14, 17, 20, 23. For question 4, it's going up in 4s, but the first number is going to be minus 6, and there'll be minus 2, 2, 6 and 10. And then finally for question 5, it's going to be 20 take away 5, which is 15, and we're going down in 5, so it'll be 10, 5, 0, minus 5, and there are your answers. Now if you have a look at this kind of extension question, so in this question we're asked to find the 203rd term of the sequence 4, 13, 22, 31 and 40. Now typically if this was like a small number that we wanted to find, so for example if we were asked to find the 8th term, then what you might find, it easier just to continue the sequence until we get to the 8th number. However, for this particular question they really are diverting you away from that method, so what they want to try and explicitly tell you is they want you to find the nth term first, then use the nth term to find it out. And it's definitely a whole lot easier than sitting there continuing this term for 198 times. So it works in your favour if you're a little bit smart and think, okay, what's going to make this question easier? Well, if I knew what the nth term was, then I could easily work out what the 203rd term would be for this particular sequence. So you think to yourself, well, let's do that first. So the first thing we want to do is find the nth term. So to find the nth term of this particular sequence, the first thing I need to do is find the difference. So if I just start by writing out the sequence again. So we can see here that the difference between the numbers is plus 9. which means that 9n is going to be in the formula. Now to get from 9 to 4, what I need to do is take away 5. So then the nth term formula is going to be 9n take away 5. Now then what we need to do is then find the 203rd term, and that's basically all we need to do is sub n equals 203 into the nth term. So what I've got is I've got 9 times 203 take away 5, and if I put that into my calculator, 203 times 9 take away 5 gives me an answer of 1822.